Hello everyone, welcome back to my channel. My name is Lian Duan, and I have developed for 20 years, specializing in DevOps and cloud security. Today we'll dive into SSH tunneling, set up an AWS environment, and create an SSH tunnel to secure access an EC2 web server on private subnet. By the end of this session, you will be able to set up your own SSH tunnel and see it in action. If you have an AWS free tier account, the demo costs around 40 cents. All video review content and slides are available on my GitLab repo. The link is below. When you finish your exercise, do not forget to clean up all the AWS resources to avoid any unnecessary cost. Let's start. In this video, we'll cover SSH tunnel concept, how it works, and a hands-on demo using AWS EC2. What is SSH tunneling? SSH tunneling, or port forwarding, allows you to securely route network traffic from your local machine to another device over an encrypted SSH connection. SSH tunnels are commonly used to access remote server behind firewalls, bypass network restrictions, securely connect to the internal service from your remote machine. For example, if a web server is running on an EC2 instance in AWS private subnet that you cannot access directly over the internet, you can use SSH tunneling to secure forward traffic between your local machine and that service. SSH tunnels provide both security and flexibility. Now we know what an SSH tunnel is. Let's explore how it works. We'll use SSH --L command. In this command, capital L stands for local port forwarding. 8080 is a local port, that's a port in your machine. The destination IP is 10.0.2.210. Destination port is 80. The port is on the private web EC2 service that you want to reach, plus SSH server login information. SSH username is EC2-user. The IP address is 52.90.2.49.30 and login private key. The command forwards local machine port 8080 traffic to private EC2 web server port 80 using SSH server tunnel. Alright, let's get ready for the hands-on demo. Before we dive into the demo, we go over the architecture of the demo together. The demo VPC provides isolated network with AWS. The public subnet contains the EC2 SSH server, which has a public IP address, allowing it to access from the internet. Secure group only open the SSH port 22. The private subnet contains the EC2 web server, which does not have a public IP address and block directly inbound internet access. The security group is only open the port 80 and 22 from the public subnet. In NAT gateway, an electrical IP is associated with the service for the processes access, located in the public subnet. It provides outgoing internet access from the private subnet, because when EC2 instance launched, it needs to download and install web server from internet. Internet gateway attached to the VPC. It allows the resource in the public subnet to communicate with the internet. Also, the SSH tunnel workflows are done in the diagram. In our demo, a user initiates an SSH tunnel from their local machine to the EC2 SSH server in the public subnet. Through this tunnel, traffic from user's machine is securely routed to the EC2 web server in the private subnet. Next, move to the demo's environment setup. The prerequisites for our demo: one free tier AWS account, Terraform installed on your local machine. I have videos on how to install the Terraform on Windows and Linux if you needed help with this. Terraform uses an AWS user, which has administrator access policy. Open my terminal. Go to the folder where you downloaded the demo code. Run Terraform version to check if Terraform is installed correctly. My version is a little behind the current release. That's fine. It's not affect our demo. If you want to see how to upgrade it, please leave comment below. Next, run Terraform init to initialize the project and download the resources. Next, run Terraform apply with auto-approve to create all AWS resources. Once the setup is complete, copy the SSH server public IP and the private IP of the web server. Then paste the two IPs in the following command and run it. Type yes. When you see the highlighted part, that means you successfully created the SSH tunnel. Open your browser. In address part, put localhost 8080. And you should see hello world from EC2 instance B, confirming that SSH tunnel is working. Before we finish, do not forget to clean up. Run Terraform destroy plus auto-approve. This will delete all AWS resources created during the demo. Avoid any unnecessary costs. Today we learned what is SSH tunneling is, how it works, and how to set it up and test in the AWS. If you have any questions, feel free to leave them below. I'd be happy to help. Thank you for watching and see you in the next video.